Alright, now that we've got our facing operation taken care of, let's exit out of our simulator, get back to our piece, noticing that we have a setup done, we've got a facing operation done. So the next thing we're going to do is a pocket. So I think the first time we do this, we'll do it as a pocket, but then in the next video, I think I'm going to try it as an adaptive and just take a look at it and see if we can notice whether one operation seems to be more efficient than another. Let's just walk through this. Good practice just to get used to the number of toolpaths that we're creating. So if I click on 2D Pocket, I want to start this operation with a 1/4 inch tool. So I'm going to go into my library and find the 1/4 inch flat, upcut, downcut. For now, it doesn't really make any difference. Downcuts are a little cleaner on edges. Upcuts often used for some roughing out of a space like what we're doing right now. So if I take my 1/4 inch upcut bit and select it, that is all I need to do for my tool. Notice all these numbers are automatically set. Next tab over, I'm going to select the actual pocket. So right now, nothing's selected. So if I go inside here and if I notice that I can select both the outside edge and the text all in one single click, I'm just going to left click on that. Sometimes it takes a couple seconds for it to register how it's going to operate, but it's going to be carving out all of that space between my two deep blue lines. There are some spaces where I'd love the tool to attack that it's not presently attacking, and that's inside my B. So if I just click on that and give it a moment, inside my E, inside A, and inside my last E. So now I have an entire pocket selected where everywhere between the dark blue lines, we'll see this as we walk through this. It'll make more sense as we start to set these operations in action. Heights again, often you can make, so it says selected contour is where it's going to hit the bottom, and that's probably the most important, is to recognize that the actual cut is going down to the bottom of the contour we just selected. It is going to start at the top of the stock, which definitely means that it'll be carving through the top layer of the wood all the way down to where we set our contour, and then these numbers are bigger. The next operations, let's see, we're going to be doing a left climb cut. Sounds all right. We're not going to leave any stock. I'm just going to unclick those ones. And then on the last tab, an interesting tab, I want the tool to stay down and try to do as much cutting without constantly popping out of the surface and jumping back in. So what I'm going to try to do is, well, let's actually execute it the way it sits right now and then see if we can notice something that changes. So if I run this, I'm going to try to create a bit more space here for this visually. So lead-ins, everything else looks all right. So if I press OK, I'm on my last tab. If I press OK, HSM takes a moment to figure out what it wants to do. And then you can always actually regenerate your toolpath. So just take a look at that, the distribution of red throughout it, meaning those are the points where the actual tool is going to be going in that 1/4 inch to try to get to that depth of the cut. If I were to regenerate that toolpath, it regenerates it pretty similarly. And then let's just go in there and simulate it quick, but then I'm going to try to make a quick modification to see if we can improve that, because right now I see that HSM wants to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. Inside of letters, there's no way about it. There's no other way for a tool to get down there and carve out without going into that gap. Uh, but why it needs to do a carve in there and there, where it could just carve in there and access that point, that to me seems like a waste of time. So we're going to see if we can improve some of these helical patterns where it's actually going to depth. But let's simulate and just see where we're at. So if I were to take my tool and uh, run my simulator and speed it up a bit, I can get a sense as to what the machine is going to be doing in order to carve out that pocket. So I sped that up quite a bit. I'm going to slow it down just a bit and watch that again. So we're going to see the tool carving out a lot of wood. That's right there. That all seemed fairly logical. Right there, not as logical. It carved out like a fraction of it, jumped up, and then decided to come down to the bottom. I like what it's doing right now, where it's not bouncing out of the material and then coming back in. It seems to be doing what it can do at depth and just carrying through, getting it as clean as possible. We haven't seemingly popped out of the material for some time, so that's fantastic. I really wish HSM would have some form of timer. It might. I need to investigate to see if I can time out how long does that toolpath take, because this toolpath is going to take some time to do all that carving. And anytime we're working with a CNC machine where it costs money to have operator and machine in action, the faster we can get this carving done, the better we can do in terms of price for our customer. All right, I'm going to stop that. I'm content with that. It seems all fine. It would work. Not convinced that's the fastest way to do it. So if I were to take that 2D pocket and double click on it to activate it and go back to that last operation, I'm going to just increase this number to a number of 5 inches and press OK. Then it's going to redesign our toolpath, and it seems like it's laid it out pretty similarly, where we still have multiple helical patterns. One thing in terms of design here, where it does seem like it's going helical to get into some of these pockets, would be to stretch our letters out so that the tool could actually make its way in between gaps between letters. In this instance, it doesn't seem like changing that number is having terrible impact on whether or not it can regenerate. So in the next video, I'm going to try an adaptive, this adaptive 2D path and see if it becomes any more efficient at cutting out that pocket space.